Alright, so in our next lecture capture video, I will be discussing the law of definite proportion, or it's also known as the law of constant composition. Okay, this was introduced by Joseph Proust from 1754 to 1826. Okay, and he proposed that the constant composition of compound that states the following: the given compound always contains exactly the same proportion of elements by its mass or weight. Okay, so that's key here. So what this is trying to say is, for example, water. We all know the formula for water, okay, is H2O. Okay, so at the time though, they didn't know what the formula of water was. For example, they always assumed that the ratios of formula was always 1-to-1. So at one point, they did propose by John Dalton that water's formula was one hydrogen atom and one oxygen atom. But that all changed based on this type of explanation, because by Joseph Proust in the law of constant composition. So even though you have water, you have no idea what the formula was. See, if you do it by careful weighing, that's the thing here. It has to be careful weighing of the sample itself. It doesn't matter how much you have. Okay. So for example, if you had either 1 milliliters worth of water, 10 milliliters of water, 100 milliliters of water, or say 1 liter's worth, or a gallon's worth of water. You know, it's different volume amounts of water, and that's the compound here. No matter what happens, the actual percent composition that's used, right, in each of these 5 different amounts have to be the same. So it has to be a certain percentage of hydrogen contains and a certain percentage of oxygen that contains. And no matter what the amount is, okay, it has to be the same because it's the same substance. It's water. Okay, so how do we apply this then? So, so it says here, let's consider the following. You have sample A that weighs 10 grams and sample B that weighs 27 grams. Okay, so you come here. Alright, so for this problem here, okay, so what do we got here? So we have here this organizer itself, so we have sample A, okay, and it has a total mass sample of water, okay, which is 10.000 grams of water. So it was weighed out carefully. They were able to determine that the mass of the hydrogen was 1.119 grams of hydrogen, and what's left over, remember for law of conservation of matter, if it's 10 grams in total and 1.19 grams is hydrogen, the rest must come from the oxygen. So I just subtract the total from this part, that is with the 8.881 grams of oxygen. Okay. Now over here we have another sample B. But please note that the sample is still water. Just weighs different. The sample total weight for sample B is now 27.000 grams. Okay, and it was found that the mass of the hydrogen that's in this amount of water was 3.021 grams of hydrogen, and for again, let's take the total minus this part. What must be left over all comes from the oxygen. 23.979 grams of oxygen. Okay? So how does this illustrate that the law of constant composition is held? Well, we do the following. We're going to take into our definition of what we consider to be a percentage. So what do we know from here? So we have the parts. So let's calculate the percent of hydrogen and the percent of oxygen that at the end, if we add them up, should be equal to 100%. That's the total composition of the substance, in this case, water. So here we go. So we have here 1.119 grams, okay, of hydrogen. That's the part divided by the total, which was 10 grams of water. Multiply 100, that ends up giving us 11.19% hydrogen. Okay, let's do the same thing over here now, sample B. So my part of hydrogen from this sample, which is 27 grams worth of water, is 3.021 grams of hydrogen divided by the total 27.00 grams of the water. Okay, times 100. So what are we end up getting? 11.19%. So notice here it's starting to illustrate it doesn't matter the amount of water added here or here. Okay, the amount of hydrogen that corresponds to this water ends up being 11.19. The 3.021 grams that corresponds to this 27 grams is exactly the same amount. This illustrates the law of constant composition or law of definite proportion is true and held only by careful weighing. Do it for the oxygen. So now we have 8.881 grams of oxygen divided again by the total. Remember, parts over total times 100. The total here is 10 of water times 100, and that's equal to 88.81% oxygen. Now I come over here to sample B. So now what we have here is 23.979 grams of oxygen divided by the total 27 grams of water here times 100. So what do you end up getting when you put in your calculator? 88.81%. So notice here, oxygen, same thing. It doesn't matter if it's 10 grams or 27 grams. The amount of oxygen that it contains in both cases is exactly the same, 88.81%. Okay, so this does illustrate that the composition, no matter what the amount is, you have with 10 grams, 27 grams, 100 grams, as long as you know what the actual fractions of each of these amounts of hydrogen and oxygen makes up this compound, the composition must always be the same by its percent weight. Okay, we illustrate here. Okay. Now notice this also, that the amount of oxygen seems to be greater than that of hydrogen, and that's kind of true because why? Well, most of it is the weight. Hydrogen is much less than that of oxygen, so most of it is dominated by the oxygen here, and less than the hydrogen. But no, and this is the percentage amount for this. Okay, so that illustrates this point here of how the law of constant composition works. And we of course have one more left to do, which is of course the law of multiple proportions. When we start getting different compounds mixed in together here, and how do we come up with a certain defined ratio, whole numbers based on compounds that have the same elements but different ratio amounts. Okay, so we'll see that next. All right.